Welcome back to Math Concepts. We are going to work on a chapter that focuses on logic. So remember, the purpose of this course is to introduce us to mathematical structures that we haven't seen before. So in the last chapter, when we were dealing with the theory of sets, the objects we were working with were sets, and the operations were intersection, union, and complement. And we could use those operations to take sets that we already had and apply those rules and make new sets. In this unit on logic, our objects are going to be things called statements. And we're going to introduce some operations that can be done on those statements to combine them together and make new ones. Okay, so it's another example of a mathematical structure that is different than the structure of arithmetic that we're already familiar with. So let's switch over to the document camera and look at some examples of statements and the operations that we can do on these statements. Okay, so by the time this video is over, you should be able to look at a sentence and determine whether it is a statement in this context. And you should also recognize the logical operations and the symbols for them. So a statement in the context of logic is a sentence that can be assigned a definite true or false value. Okay, so not every sentence is a statement. Let's look at some examples. So we will determine whether each sentence is a statement. Okay, so this first one says, Harvey Mudd College is in Oregon. Okay, this is a statement. And I believe it happens to be false. Harvey Mudd College is actually in California, but that doesn't make this not a statement, okay? It can be assigned a definite true or false value. It happens that the value is false, okay? So that is a statement. And we can all agree on what the truth value is. All we need to do is look up the location of Harvey Mudd College. Okay, so number 2 here, Star Wars Empire Strikes Back is the greatest movie of all time. That is a sentence, but it is not a statement. Okay, this right here, we can look up where Harvey Mudd College is and determine whether it's true or not, whether the statement is true or not. This is an opinion. Okay, so there is no definitive way that we would all agree on to say what's the greatest movie of all time. Here, do you like to read? This is not a statement. That's a question. Okay? Now, you could answer the question, you could say yes or no, okay, but that doesn't make this a statement. Okay? So a statement has to be a declarative sentence, and we have to be able to assign it a definitive true or false value. So things like opinions are out. Okay. So statements will be the basic objects that we're going to work with in this unit on logic. Now, to have a mathematical structure, you need objects and you need operations. Okay, so let's look at what the operations are that we do with statements. Okay, so the logical operations. So the first is the operation of negation. Okay, we'll often just let a letter stand for a statement. So P is some generic statement, whatever it is. Okay, and we use this symbol right here. It's a tilde. We use that for not P. right? And this is a tool that we'll use quite a bit throughout this unit. It's called a truth table. Okay, so P is some generic statement. We don't know what it is, but we know it's got to have a value of true or false. If P is true, then the negation would have a value of false. If P is false, then the negation would be true. In other words, not P has the opposite truth value compared to what P has. Okay? Another operation that we can do with statements is we can take two statements and put them together using the AND operator. Okay, it's very easy to remember here. The symbol that we use for the AND operator, it looks like an A. Okay, so P and Q. And this is the truth table here. Notice that when we apply the AND operator, the only time we get a true is when both of the parts are true. Okay, so we got the AND operator joining two statements together. That new statement is only true when both of the component parts are true. Another operator that we can do to form a new statement is we can put two statements together using the OR operator. The symbol here is just the upside down version of the one we use for AND. All right, so here's the truth table. Okay, these are the possible values, the possible truth values of the two statements P and Q. And in this last column, we're talking about the truth value of the new statement P or Q. All right, so notice that the only time this is false is when they're both false. Okay, so if you put two statements together using the OR operator, you're going to get a true statement when at least one part is true. Okay, so I want you to compare these two truth tables. Okay, when you put things together with the AND operator, it's only true when they're both true. When you put statements together with the OR operator, it's true if either one of them is true. Okay? So we'll look at examples in the next video of putting statements together with these operators. There's two more operators I want to show you. So, okay, so another operator is this conditional operator or an implication. Okay, it's an arrow here. So it's read, if P then Q. Sometimes people might say P implies Q. Okay, this is the truth table right here, the various truth values of P and Q, and then the truth value of the conditional statement. Okay, so it might be best to think of an example here. Look at these truth values here. Notice the only time the conditional is false is when the starting statement is true, but the ending statement is false. Okay, so let's look at this example here. Let's let P be the statement, you clean your room. Q is the statement, I give you ice cream. Okay, so this would mean, if you clean your room, then I will give you ice cream. Okay, so let's imagine that a parent said that to their child. If you clean your room, then I give you ice cream. Okay, so let's think about the truth table. What I want to think about is, under what conditions can we say the parent was lying? Okay. Clean room, we go get ice cream. So the parent was telling the truth. let's look down here. Did not clean the room, we went and got ice cream anyway. The parent was still telling the truth, okay? They were just being lenient. This is, the room didn't get cleaned and we didn't go for ice cream. So you can't really say the parent was lying. The parent said, if you clean your room, then we will go get ice cream. So the only time that you could say that the parent was lying to the kid is if the kid cleans the room and they don't get ice cream. Okay, so the only time the implication is false is when the starting statement, called the premise, is true, but the conclusion is false. Otherwise, the implication is true. Okay, so the last operation that we'll be using in this unit is called the biconditional. It's a double arrow, and the English way, the English sentence version of it is P if and only if Q, and here's the truth table right here. Okay, notice you got a true up here and a true down here on the bottom. Okay, the way to summarize this is the biconditional is true when P and Q have the same truth values. So if the parts are both true, then you get a true. If the parts are both false, then you get a true. If there's a mix, then the biconditional is false. Okay, in other words, the biconditional is a new statement that is trying to determine whether or not these two component statements are the same. Okay, so I'm going to post these notes. Make sure that you study the basic truth tables for the logical operations that we went over in this video, and make sure you remember the symbols for the various operators. Okay, we had the operator not. We had and. We had or. The arrow was if blank, then blank. And the double arrow, if and only if. Okay? These are going to be the operations that we use to take statements and combine them into new ones. Okay, so you got the negation. You could join two statements with and, or, the conditional, or the biconditional. In the next video, we're going to talk about some specific examples of what these operators do.